Hello folks, welcome back to Oxygen Not Included. Today we start with a bit of renovation on our petroleum boiler. It turns out that you can see there's a little blob of lead falling in, and you might wonder where that lead is coming from. It seems Dupes have decided that we ran out of copper, so instead we'll just use lead for the radiant liquid pipes. Oh well. You can see all the places where they have used the radiant liquid pipes made out of lead. We literally have to open up the petroleum boiler, deconstruct everything, stop everything, and just go and replace everything that is made out of lead with copper. Because lead has a melting point of 350 degrees Celsius, which is way below our petroleum temperature. So I'm going to do some remodeling, deconstruct some of these things, and see where we land. Done. So we just opened up this petroleum boiler, went inside, replaced everything. So if you can see here, everything on this side is made out of obsidian. All the pipes are made out of obsidian that are going to be carrying magma. These couple of pipes are made out of ceramic because I wanted better insulation on these ends, so that's why there's a little bit of ceramic. Everything else is made out of sandstone, and if I click on metals, now everything is made out of copper. So hopefully this should work. So right now we have 180 kgs of oh, crude oil. That's good enough. So I'm going to start it by setting the temperature, and it should start sucking the temperature from here. We do not have a lot of temperature just yet, so that's why we are bringing in more magma, but it should automatically start rising this temperature up or raising this temperature up. We also did a little bit of piping, moved around stuff, so now my polluted water is going this way, one petroleum line is going this way, other petroleum line came on this way, and there is a little bit of indentation over here. What I want to do is I want to have a place where I can refine all the wood into ethanol. So I know I don't have access to wood yet, but I can still plan for ethanol. So I'm thinking of let's putting like four ethanol refineries. One second, not like this. So first of all, I need to burn off ethanol. So power wise, I'll just take a petroleum generator and put it somewhere over here. So I think I need to move all of these power lines because I want to put petroleum generator right over here, which is overlapping with this port right now. So it's okay. I can just move it two tiles this way. That's fine. Done. We moved all the power wires to one tile to the left. So now we can start planning how our final brick is going to look like. So first of all, I'm going to put a petroleum generator right over here made out of copper because we don't really care. Priority 1. And refinement wise, let's just plan out distillers as well. So we need 4 of them to run one petroleum generator. So this is perfect because this way we can get all of them. I just need to put some collection points like this, but that's okay. This is just going to help collect all this ethanol into a single pipe of full of 2 kgs, and this way we can just put all of the ethanol into a burner, that is petroleum generator, or right over here. Priority wise, all of this can go to 1. I don't really care right now. We can ship lumber somewhere over here, put them right here, and this would be our end of the line. So we can have our ranch somewhere over here, and that ranch can literally stay right here without us having to worry about anything. So this can be something like this. You can have a auto sweeper that can cover the whole ranch itself, and obviously we need some shipping. So this will be our overall design of our ranch. This would be the size internally, and that way we can have perfect ranches with perfect industrial utilization. and these ranches will be totally cooled by our cooling loop, so we don't have to worry about things overheating. You can see it up top here. All of these ranches are starting to get overheated, so I'm going to move all of these hatches down here. So we have three ranches right now. Later on we can put in different kinds of creatures right here. Done. So what we did is we just made a couple of new ranches. I'm just going to copy the settings up from up top, and they just follow the same pattern where we are going to starvation ranch a bunch of stone hatches. We do have a couple of random stone hatches here that we can move, and I'm going to start decommissioning this ranch. So this ranch is going to go to 0, and once these hatches die off, we are just going to move them downstairs. So two of the ranches are going to get decommissioned up top, and two of them will start here. Now all I need to do is make sure that I have enough power. Power wise, I'm just going to use a petroleum generator made out of copper ore just because, and you can see here I can put 1 2 3 4 5 and 6 generator comfortably. And room wise, this is still 96 tiles, this is 96, this is 96, this is 96, so all of them is well and good. I just don't have enough copper ore just yet, so I'm just going to make only one at this point. But we should have enough petroleum coming in from here as well as here. So if I take a look at my petroleum line, there's one petroleum line here and one there. So one petroleum line can run 5 generators, because 2 kgs per generator, and it's 10 kilogram packets, so you can run 5 and we can run 6 because we have one extra generator that is gonna be supported through this petroleum line. I'm also going to deconstruct a little bit of this and expand on this area. I want to have a place where we can refine all the polluted water that is coming out here into fresh water that we can feed back to these oil wells. So that is what I'm going to do somewhere over here. I think this is a decent enough space that we can put refinement. Yeah, we can easily put a water sleeve right over here, and it should work exactly as we want it to be. And it's ready. All we need to do is put some sand over here. Dupes can bring up the sand here. I'm just going to put it at lower priority. Plumbing wise, you can see we have polluted water that is going up this way. We can certainly move this polluted water just a tiny bit here to connect it to our water sleeve. So now this polluted water can also go in water sleeve and go up, and this water sleeve has started. We have already powered it up. Automation wise, we have simplified the automation so that if there is not enough oil here, this water sleeve will start churning out water, and that water is just going to go up and down in these two oil wells. And the reason for that is I didn't want water to be sitting right over here if the oil wells are disabled with automation, because if I do that, this water can sometime flash into steam, which is horrible. So this way the water will get consumed and new water will stop, and if the new water has stopped, this oil wells will stop automatically. Now you can see here I put a little bit of 4 kgs of petroleum over here because I didn't want it to off gas polluted oxygen all the way over here. So that's why this is there. This is a perfect vacuum, and I would love to keep it as a perfect vacuum with no polluted oxygen whatsoever. So that will be our design for water purification, and we no longer are going to depend on the water that is coming from here, because you can see we are running really low on water right now. I need to import some water from other planetoid. We are using a lot of water to fill up our oxygen as bristle blossoms. You can see bristle blossoms are really hungry. We are bulking up on calories, but we are shy of 1 million a lot. So yeah, I'm not really comfortable just yet turning off all the calorie generation with water. But that's okay. We have supplemented our water supply, and our petroleum boiler is also up and running. It has started pushing petroleum all the way over here. So temperature wise, you can take a look at here. This is nice and balmy, 4 or 8 degrees Celsius. It is going down and down and down. It's 140 degrees Celsius, and gradually it will even, I guess, stabilize over time. Right now we are churning through a lot of magma, and that is kind of expected. In like 10 cycles now you can see petroleum boiler is up and running, and output temperature here is almost 402 degrees Celsius. That is pretty good, because oil will flash to petroleum at 405 degrees Celsius. So that's why I turned down the temperature here in this sensor to 400 degrees Celsius, because it will gather more heat just during the time when the door is closed. So that's okay. So I think it's time that we up our intake. So let's make it 2000, 2 kilogram per second, and see how our petroleum boiler does. The temperature here is staying around 580 degrees Celsius, even though I'm setting it right now to 700. So I think 580 is gonna be more or less the stable temperature here, and it is going to constantly eat magma. So the looping mechanism is of no use right now. That's fine. We are still going to churn through a lot of magma. Maybe later down the line what I'll do is I'll just remove the loop and just make the magma flow one way. This way we don't have a problem of magma, going up and combining into a blob that is bigger than 1 kilogram. But that's for later. We cannot afford that much magma just yet. But once this fills up, we can start pumping it into our petroleum generator. This is waiting and dying for petroleum to come in. We just plumbed in this way, so it is going to get filled in to this pipe, and this pipe is coming from our slickstress. So we kind of want to use all the petroleum generated by slickstress before using the petroleum that is coming from our boiler. So while we are running this petroleum boiler, I upped it up to 5 kilograms per second, and it is staying constant at 500 degrees Celsius because I made a little bit of arrangement in magma, and I'm just shunting out all the magma by raising the temperature here to maximum. Magma can never reach this temperature, so this can never go back in the loop. And right now I'm bringing in around, I believe, 50 kgs. Yes. So let's see how this well does. You know what? I realize that we are never going to use this much surface area in our steam brick, because ultimately we don't need a lot of batteries. We have non-stop petroleum generators which are going to generate a lot of power, so we are never going to be using that many batteries. We have ton of oil in this planetoid, so there is no point in using any other power source as well. And I can't imagine any putting any other machines in here. So what I was thinking is, might as well squeeze this steam sauna a little bit smaller, so that we can just squeeze in our oxygen generation right over here, which is right next to our atmosphere docks, right next to our base, right next to our cooling solution, as well as we can pump up that oxygen into our rockets right over there. So I am thinking, not here. So what I'm thinking is just squeeze it down a bit, align it so that all the power steam turbines are on the same level. I know I have like a very weird compulsive disorder that I would love to have all the steam turbines on the exact same level. I do not know why. So I'll just squeeze them, all of them down, drop this one tile down so that we can have enough space for our generators and thermo aqua tuners, one or two spaces even. And yeah, we can go from there. So let me just clean it up. I'm also going to squeeze this little bit so that we have a smaller natural gas geyser tamer. So I'm just going to move this gas pump one tile up. This is such a mess. I need to clean it up. So yes, I need to do some rejigging. So I'm going to move all of the transformers to the bottom here. It should be next to our aqua tuners. We have two rows here for batteries and transformers, one row for two of these metal refineries, and a little bit room for these steam turbines. So I need to make this a totally vacuum room. So for that, what I'm thinking is I'm just going to break it up and open it up from the this right hand side so that it will be perfect vacuum. And this is just a vanity project, and this one has literally no real meaning other than me just doing something stupid, but oh well, that is the channel. You can also put a blob of naphtha here so that we have a secondary access over here. Yeah, I'm just going to break this up and let these steam turbines eat it. So they can eat up all the steam and just pump it out this way. So we can move all the steam from this place to this place. All we need to do is heat up the steam beyond 125 degrees Celsius, and I think we should be able to do that with just the help of transformers and a little bit of refinement. I stopped refining iron just yet. We have plenty of iron ore that we can start refining. I started digging some of the iron ore from here. There is a little bit of a lot of iron ore somewhere over here. I think it is time to move all of our power transformer from up top to down here. So these power transformers are plugged in, connected and ready. We can just snip the old power supplies, and this way we can easily transfer the power without overloading our circuit. Done, done. And we can now deconstruct all of this junk. And now these things are done, what we can do is we can just easily condense this steam that is only just 14 grams with nothing but just temp shift plates, and it should not carry more or drag more heat from the heat sauna because there's not much mass to drag the heat. I'm just going to deconstruct all these things so all the hot things get out of here, and we just have temperature shift plates made out of just granite. And printable wise, let's see, just get the brine. I would love to get some of these dupes, but not yet. I'll try to get dupes during our space missions, but not before that. Just because the steam is so little, it is automatically condensing and getting deleted. So right now we are at 14 mcg. It should clear out at any moment. This is a perfect vacuum. Now we can move all of our steam turbines down here, and this area we can literally build a nice, I guess, oxygen contraption over here. And I think I'm going to settle for this design. So this design basically has normally 4 of these oxygen diffusers, electrolyzers, and we have 6 gas pumps and a hydrogen generator. I'm going to put yet another hydrogen generator over here, and one generator can go on top. This we need to move one tile up, and rest of it can be thermally connected directly here, so we can reuse all that heat. So that is the idea behind this generator. Now you can see ventilation wise, one oxygen pipe is directly going to come here and oxygenate our base. 2 other pipes are going to go to, one of them is going to go to our atmosphere stocks, and another one is going to go to our rockets later on. So this will serve for many cycles to come. And that is the best part about this electrolyzer design, that you build it once and then you can use it again and again. So it's almost ready. We just need to put in 1 kg of liquid on bottom layer and 1 kg of different liquid on top layer. So I'm just going to use crude oil and petroleum. I have, this time I'm going to measure it properly. So we need 1 2 3 4 5 6 7 8 kgs of liquid in total, and we have restricted our liquid output here in the liquid valve. You can see this is currently restricted to 2 kilograms. So if I take a look at liquids, it should spit out 2 kilogram blobs that is going to spread out properly. 1 2 3 and 4. Yep, looks about right. Now next, liquid petroleum. So let's just deconstruct all these pipes and just get some petroleum over here. So I think our oxygen production facility is almost ready. We have 4 of these electrolyzers made out of steel. Everything is made out of steel. All the gas pumps made out of steel. 3 hydrogen generators, 1 battery, 1 big power transformer that is going to support everything in here, and 1 small transformer to support only this gas pump, because we need slightly more than 2 kilowatts to support everything. If I click on power, you can see here This one has a maximum consumption of 1920 watts, so it's almost at capacity, and we can tap into this later on if we need. Now all we need to do is prime this sucker up, because without priming this is not that useful. So I'm going to move a little blob of oxygen from our atmosphere stocks over here and move all the oxygens in this area. Okay, Steve is bringing it, so I'm going to cancel rest of the move command. Oh, never mind. See, just move this amount of oxygen. We don't want the whole 11 tons of oxygen here, just a tiny bit. And this way hydrogen should go up, get picked up by this gas pump. Ventilation wise, you can see this gas pump is directly going to push all the hydrogen down here into these three generators, and all the oxygen is going to get pushed. One oxygen is going to get plugged into our atmosphere stocks, another oxygen is going to get plugged into our base. So let me empty this. Somebody come in and empty, please. And these are all liquid lock. So there's a liquid lock here, there's a liquid lock here, and I'm going to break it up later on, because right now I just want to have a little bit maintenance, or ability to have maintenance in here. I'm also going to open it up this side so that all the steam can flow in, and we should be able to cool everything with just our steam brick. Right now I'm just connected a single steam turbine here. And cooling wise, you can see I have connected it to our main cooling loop that is run by this aqua tuner, and it is cooling our base as well as it is trying to cool this thing. I've disconnected this cooling loop and I'm going to decommission all of this area later on. This is no longer useful to us. So let's see. Okay, oxygen is here, wonderful. So let me connect the water as well. So this one gets connected directly to our water pipe. Water will flow in, it will cool a little bit of these gas pumps. We just want to make best utilization of our water and directly go into all of these electrolyzers. Power wise, I'm just going to connect it to our main power grid right over here, and this way everything should be powered. Why is it not powered? Oh, because of this switch. Sorry, I forgot. So this switch actually is interesting. So this switch works in a different way. So what I did is I created an automation here. What it says is, automation wise, I'm going to manually flick it off, that if the battery is below or running low, it will kick on these three generators. But if the generators are running and battery is still not able to charge up, that means we are consuming more power that our generators can provide. So it will disconnect the power grid, main power grid, from our generators. So this way we can double duty the generators, that they can support our main power grid when needed, but if not needed, then it will disconnect from main power grid and only support our oxygen generation. Now the second utilization of this is gonna be simple as that. So what happens is, this is going to draw power from our main power line as long as battery is full or battery is getting full. And this way what we can do is we can collect a bunch of oxygen here without us. Yes, hydrogen is here and oxygen is here. Yep, that is spreading out milligrams. So material wise, if I click on gases, yes, hydrogen is up top, oxygen is going here, and this is just open top kind of a generator. So all I need to do is just break it up so nobody can mess the fine I guess symmetry of this system. Okay, so I'm getting distracted. So this way we can run all of this oxygen generation with just our main power grid, and we can collect up on hydrogen, and this hydrogen can be used for hydrogen rockets later on, and that way it just acts like a double duty. We have a lot of spare power. Okay, done. This is connected. Now automation wise, I'm also going to connect hydrogen extraction. So this is going to run when hydrogen is about 20 kgs. I want to have 20 kgs of pressure just for no good reason. and this should be below, and this should be above 20 kgs. So 20 kgs is gonna be my minimum pressure that I'm going to keep in the top and the bottom, just so that I have a little bit of spare oxygen if needed. And now for the most important part, we need to deconstruct this. This is the most jarring part because I'm going to ruin my perfect vacuum here. But we need to do that to cool all of the system. Yes, the steam is flowing in and everything is made out of steel again, so nothing should overheat. And all of this heat is going to get eaten by our steam setup here. So let me just go ahead and connect everything up. So now we have enough oxygen coming in, enough hydrogen coming in, so this is going to get connected to our main line. I'm going to disconnect this. Pumps should kick in anytime you like. Come on, why are you not running? Disabled by automation. Oh, sorry, I disabled the automation. My bad. So ventilation wise, let's just reconnect these two lines. I'm going to disconnect this, and our whole base is now going to get oxygenated by these two soggy SPOM. Okay, that's enough of that. And now finally we can start deconstructing this monstrosity. I hated this contraption since I made it from day one. It was a temporary bridging solution that we wanted to have. So I think this is a good point to end this episode. We have created a soggy SPOM. We have reconstructed all of our production to this thing, and we have also started using a lot of this polluted water directly from here. It is going in through now our liquid shut off. This liquid shut off is controlled by this automation, and the whole idea here is we just want to run these oil wells when this oil level is below certain level, and this way we can move all the water here to priority at oil wells, and oil wells will consume all of this water, so none of this water should stay in the pipe, breaking the pipes later on. Rest of the water gets shunted out up top here and get bridged on top to feed our bristle blossoms. Right now this water is coming in from two sources. One source is our normal cool seam vent, and another source is the toilet water. So I kind of want to use the toilet water up because it's backing up, so it is just going to get pumped in back into our bristle blossoms. In the next episode, I think I am going to work towards a space program. We need to start doing space research sooner rather than later. And we have another long hair larva. And we have enough oxygen that we can support long hair slicksters. We will also clean up all of this area, remove all of this gunk, and work towards a nice recreation room and finish up this geyser taming. This is like a half-baked setup where I wanted to have it, but still it's not fully completed yet. So I hope you folks like this episode. Hope to see you folks next time.